So in that way, we'll be able to solve more amount of questions. So let's start. Okay, can everyone see this PPT slide, 3D coordinate system? Type in yes if you are able to see the slide. Okay, yes, from Ritvik. So I'm going to assume that others can also see this slide. So let's start. Uh, we have considered two axes, which are x and y, but in 3D, we are going to consider three axes, which are going to be our x, y, and z. So this is nothing but your three-dimensional system. Regular Cartesian system is your x axis and y axis, which are mutually perpendicular to each other. On one side, we have positive numbers. On other side, we have negative. We have origin at 0. In 3D, there will be another line, which is a z-axis, and this is also going to be perpendicular to your x and y-axis. This line is again going to be passed through your origin, and z-axis is also going to be perpendicular to x and y-axis. There are going to be three planes. One plane will be going through your x and y axis, so that's going to be your xy plane. Other plane would be your yz plane, and the third plane would be your xz plane. So this is your xy plane, the yz plane, and the xz plane. The three planes are going to be as shown. If there is any point P, in a 2D system we have coordinates of P as x and y, but in 3D we'll have coordinates of P as x, y, and z. If that P is going to be parallel to yz plane, then that means that it is going to meet somewhere at x-axis. If that plane is going to be parallel to xz plane, then that means that it is going to meet somewhere at point B. And similarly, if that plane is parallel to your xy axis, xy plane, then it means that it is going to meet somewhere at point C on z axis. We can find the distance from origin. If that point lies on, if there is a point A which lies on x-axis, the magnitude is nothing but magnitude of that point x. Similarly, magnitude of y and magnitude of z would give you the values. So this is just the representation of a point. So in this case, there is a point which lies in xy plane. What would be its z coordinate? So as it is lying in xy plane, its z coordinate is going to be 0. If it lies in xz plane, so it has an x coordinate and it has a z coordinate. It doesn't have any y coordinate, so its y coordinate would be 0. And similarly, if there is a point P which lies in YZ plane, then in that case, its x coordinate is going to be equal to 0. Consider a point which lies on y axis. If there is a point which is lying on y axis, it will only have y coordinate. It won't have x and z coordinate. So x and z coordinates would be 0. Similarly, if a point lies on x axis, it will only have x coordinate. Its y and z coordinates would be 0. For a point which lies on origin, I can say that its x, y, and z coordinates are all going to be equal to 0. The three coordinates system is going to divide into equal 8 parts, x, y, and z. So in first quadrant, it's going to be all of them are positive, and similarly. Two points or more than 2 points will be collinear if they are going to lie on a same line. So if there are 3 points and I have to show that the 3 points are collinear, I can show them in this way. AB plus BC is equal to AC. So addition of any two sides should be equal to third side. The question can also come in this way. Show that area of a triangle is 0. When will area of a triangle be 0? Area of a triangle would be 0 if the 3 sides of that triangle are collinear. If the 3 sides are collinear, that triangle won't have any height, and hence, even if you apply the formula of half base into height, area of that triangle is 0. So I'm going to assume that till here everyone knows everything. It's very basic. Does anyone have any doubt till this point? Up to this slide? Type in yes or no. Okay, so no doubts, perfect, no doubts. Okay, good. 3 or more points will be coplanar if the box product is going to be equal to 0, and 3 or more points can be collinear if I am able to show them in the following manner, where addition of two sides is equal to third side. I can also say that 3 points are collinear if I can represent them as scalar multiples of each other. For example, if I find AB bar and I find AC bar and I show that AB bar is equal to K times AC bar, then I can say that the 3 points A, B, and C are collinear points. The distance between 2 points, this is your distance formula. If I have 2 points x1, y1, z1 and x2, y2, z2, then the distance between them can be easily found by using this x1 minus x2 square, y1 minus y2 square, plus z1 minus z2 square. I can also write this as x2 minus x1 square, plus y2 minus y1 square, plus z2 minus z1 square. As it is square, writing in inverse order won't make any difference. If you're going to consider the distance from point origin, obviously one of the point is going to be 0, 0, 0. Therefore, x1 minus 0 square would just be x1 square. So the distance of any point from origin is equal to under root of x square plus y square plus z square. Distance of a point from x-axis. We are going to check the distance from x-axis, so its x coordinate is going to be 0 at that time. Therefore, the distance is going to be under root of y square plus z square. If you want to check the distance from y-axis, at that time its y coordinate won't be there. The distance is going to be under root x square plus z square. If you want distance from z-axis, the formula is going to be under root of x square plus y square. So this is your formulas. The distance of a point from x-axis would be under root y square plus z square. Suppose I want to find the distance from an xy plane. Now the point is going to lie in x and y plane. So at that point, its z coordinate is going to be the distance. Notice that the z coordinate is written in modulus sign. So if the point coordinates are 2, 3, and minus 4, and my question is that find the distance of this point 2, 3, minus 4 from xy plane, the answer is going to be equal to 4. The z coordinate in this case was minus 4, but the distance cannot be negative, so we are going to take modulus of that. So modulus of minus 4 is 4. So consider the same question. There is a point, say suppose 2, 3, minus 4, and I have to find the distance of this point from YZ plane. As it is YZ plane, the distance is going to be equal to mod of x. The point which I was talking about is 2, 3, and minus 4. So x coordinate is 2. So my answer would be 2. And for ZX plane, the answer should be equal to your y coordinate. Uh, the example that I was talking about is 2, 3, minus 4. So my y coordinate would be 3. We'll look at some of the basic questions. There is a point P, x, y, and z, which lies on this plane, 1, 2, 3, and 4. So which of these are true? If a point P is going to lie on xy plane, then its z coordinate will obviously be 0. It will only have x coordinate and y coordinate. If a point lies on xz plane, its y coordinate would be 0. And similarly, if it lies on yz plane, its x coordinate should be 0. So all the three of them are true. Hence, I can say all of above. Okay. So there is one point which lies on xy plane, yz plane, zx plane. So the point over here is 3, 2, 0. It has x coordinate, it has y coordinate, z coordinate is 0. So as z coordinate is 0, the z term is not present. I can say that it's going to lie on xy plane. So answer is equal to xy plane. The point 0, 0, 7 lies on x-axis, y-axis, z-axis, or none of the above. The point lies on x coordinate is 0, y coordinate is 0, only z coordinate is present. So z is equal to 7. That means it lies on z-axis. I have to find the distance of point 2, 3, 4 from origin. The distance from origin formula is under root of x square plus y square plus z square. So under root of 2 square plus 3 square plus 4 square. So that is going to be 2 square is 4, 3 square 9, 4 square is 16. So how much is that? 16 plus 4, 20, and 9, 29. So answer is under root 29. The distance of a point 3 minus 2, 5 from x-axis is equal to question mark. Now here it is mentioned that I have to check the distance from x-axis. So when I have to check from x-axis, I'm going to consider my yz coordinates. The formula is going to be under root of y square plus z square. So answer is equal to under root of minus 2 square plus 5 square. Minus 2 square is 4, 5 square is 25. So 25 plus 4 under root of 29. Answer is equal to under root 29. Suppose in this same question, I have to find distance from y-axis. What would be my answer? So type in your answers. My question is the distance of point 3, minus 2, 5 from y-axis is equal to question mark. I have to find from y-axis. So I'm going to use the formula under root x square plus z square. So what is my answer? You have 30 seconds. Type in your answer. Root 34 from Rutvik. Okay. Others. Mrunal is saying root 34. Okay. Others also type in your answers. Location, Neha are also saying root 34. Any other answers from anyone? So it's pretty straightforward. 3 square 9, 5 square 25, 25 plus 9 is 34. Next question would be find the distance of the same point 3, minus 2, 5 from z-axis. So answer is question mark. So what would be my answer from z-axis? Type in your answers. Root 13. Perfect. So from z-axis, so I have to find under root x square plus y square, under root x square, 3 square 9, y square minus 2 square is 4, 9 plus 4 is 13. So good, Rutvik, Neha, Mrunal, under root 13 is correct answer. Next, find the distance of this point from origin, 3 comma minus 2 comma 5. I have to find the distance from origin. So what would that be? Okay, root 38 by Neha, 38 by Ayush. So perfect. Rutvik also root 38. Good. So from origin, the formula is going to be under root x square plus y square plus z square. Okay. Also tell me what would be the distance from its xy plane. You can also tell answer of this one. The distance of point 23 minus 9 from xy plane is question mark. So 9, Rutvik is saying 9, Ayush is saying 9. So simple. Distance is going from xy plane. So distance is going to be equal to mod of z. What is z in this case? Minus of 9. We are seeing distance. So we are going to ignore minus sign. So answer is going to be 9. What would be the distance from YZ plane? The distance of 2, 3, minus 9 from YZ plane is question mark. So what would it be? 2. Location I is saying 2. Mronal is saying 2. So perfect. It's going to be x coordinate, which is 2. If the distance between the points this and this is given as 9 units, I have to find the value of x. Distance is given to you 9. So you can directly use your distance formula. What is your distance formula? Under root x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. x1, y1, z1 in this case are 5, minus 1, 7, and x2, y2, z2 in this case are x, 5, and 1. Distance is given as 9 units. So use your formula, distance formula. Distance formula is this. Just simplify this. Simplification to cancel out the square root, we are going to square on both sides and we get an answer. So I'm not going to explain the steps. I'm going to assume that you are able to solve the steps. Show that the points are collinear. So I have to show that these 3 points are collinear. In what way can I show this? There are multiple ways. If I want to show that these are scalar multiples, I can say let point A be 3, minus 2, 4, and the point B, and third point be C. And I can show that AB is equal to K times of AC. Even if I show this, I can prove that the points are collinear. Another way of showing that the points are collinear is I can find values of AB, AC, and BC and show that addition of 2 sides is equivalent to third side. So consider that A, B, C are 3. We have many conditions of this. Suppose we use this condition of showing that 2 sides is equal to third side. Even if we show this or prove this condition, we can see that my points are collinear. For that, I'll need to find AB, BC, and AC. I can find them by using my distance formula. I get my answers as root 22, root 22, and this. So what I can do, I can take common, my AC is going to be 2 times of root 22. So I can say that AC is equal to AB plus BC. Root 22 plus root 22 is 2 times of root 22. Therefore, AC is equal to AB plus AC, sorry, AB plus BC. That means AB and C should lie on the same line. They are lying on same line means that they are going to be collinear. As I said, question can also be asked in this way, that find the area of this triangle. If A, B, and C are sides or points of this triangle, then as A, B, and C are collinear, area of that triangle would be equal to 0. Show that the 3 points form an equilateral triangle. What is the necessary condition to show that the 3 points form an equilateral triangle? I have to show that the sides are equal. So I'll consider 3 points as A, B, and C. I'll first find value of AB, then I'll find value of BC, and then I'll find value of AC. If all these 3 values are same, I can say that these are sides of an equilateral triangle. So let ABC be the sides. I have found AB, which is root 6, BC, again using distance formula over here, which is root 6, AC, again using distance formula over here, which is root 6. And all 3 of them are same, therefore I can say that they form an equilateral triangle. I have to show that the 4 points A, B, and C form a right angled isosceles triangle in this particular case. To show that it is a right angled triangle, I can show that the hypotenuse square is equal to square of its adjacent sides. So if B is going to be my right angle, then I have to show that AC square is equal to AB square plus BC square. I have to also show that the 2 sides are same to prove that it is an isosceles triangle. So again, I'll do the same thing. I'll first find AB, I'll then find BC, and then I'll find AC. I'll find the relation between A, B, BC, and AC. And if 2 sides are same, I can say that it's an isosceles. So using distance formula, I'm going to find AB, BC, and AC. I can see that values of AB and BC are 18, sorry, under root 18. So obviously AB and BC are my 2 equal sides, therefore it's isosceles triangle. I have to also show that it's an right angled isosceles triangle. To show that it's right angle isosceles triangle, I have to show that AC square is equal to AB square plus BC square. So let's find value of AC. Okay, and AC square is equal to 36. Therefore, I can say that AC square is equal to AB square plus BC square. Therefore, it is right angle triangle, and therefore it is isosceles triangle. Both conditions are met, hence I can say it is true. Does anyone have any questions till this slide, or we'll move to another slide? You can type in yes or no. No, no doubts from Neha, Ayush. Okay, good. Are you able to see my screen now? Type in yes or no if you are able to see the screen or not. Okay, yes, from Rutika and Neha. Good. So let us see next slide. We'll see section formula and a few of the questions which are based on section formula. We know section formula, there is going to be internal division, there is external division. For internal division, I can say that I'll try to save this. Yeah. For internal division, formula is going to be Lx2 plus Mx1 upon L plus M if A and B are divided in the ratio of L and M, where points of A are x1, y1, z1, and points of B are x2, y2, z2. For y coordinate, it's going to be ly2 plus my1 upon l plus m, and for z coordinate, it's going to be lz2 plus mz1 upon l plus m. This is for internal division. For external division, it's going to be a minus sign between there. Therefore, for external division, if I write the formula, it's going to be lx2 minus mx1 upon l minus m. Similarly, I can get my y and z coordinates. So this point is important. If there is one point P which lies in the line, suppose there are 2 points A and B, and I'm drawing a line between these 2 points, and there is one point P which is lying on that line, then that point P is going to divide AB in this ratio, which is x1 minus x, x minus x2, or that is also equal to y1 minus y upon y minus y2, or z1 minus z upon z minus z2. Therefore, I can say that if there is any point P which lies on a line when I'm going to join the 2 points A and B, that point P is going to divide that line AB in this ratio, either x1 minus x upon x minus x2, or this or this. The ratios are going to be same for x coordinate, y coordinate, and z coordinates. So this is an important point. If there is a line segment which is joining 2 points, say suppose A and B, and it is divided in the xy plane. If it is going to be divided in xy plane, the ratio is going to be equal to its z coordinates, so minus of z1 by z2. If it's going to be divided in the yz plane, then the ratio is going to be equal to minus of x1 by x2. And if it is going to be divided in the zx plane, the ratio is going to be equal to minus of y and y2. If it's xy plane, take the third coordinate, z1, z2. If it's yz, take minus and the third coordinate, which is x1, x2. Similarly, for zx, it's going to be y1 and y2. Midpoint formula basics, just add x1, x2 divided by 2. That's going to be a midpoint. Centroid of a triangle, add x1, x2, x3 divided by 3. For y coordinate, add y1, y2, y3 divided by 3. For z coordinate, add z1, z2, z3 divided by 3. Tetrahedron, it's a triangle, you can say, with which has 4 points or 4 vertices. So there would be 3 triangles inside it. It would have 6 edges, which are AB, AC, BC, as you can see. A regular tetrahedron is when all the sides of your tetrahedron are equal. Centroid of tetrahedron, for centroid of triangle we have formula, which is x1, x2, x3 upon 3. For centroid of tetrahedron, formula is x1, x2, x3, x4 upon 4. So add all the x coordinates. As there are 4 vertices, you'll have to add x1 plus x2 plus x3 plus x4 and divide that by 4. So centroid this. So the formula for centroid is as shown. If you want to find y coordinate, it's going to be y1 plus y2 plus y3 plus y4 divided by 4. Also, the centroid of a tetrahedron is going to divide the line in the ratio 3:1. So this is also important when we are going to solve questions. Locus is when a particular set of points which are going to satisfy a predefined condition. For example, I can say that locus of a circle is nothing but all the points which are lying at same distance from origin or from a particular center. So if I consider center and draw equal points which are equidistant from that center or from that origin, I'm going to get a circle. So set of points which satisfy any condition or property is nothing but your locus. If you are going to move your origin is going to be 0, 0, 0. But if you shift your origin to, say, suppose another point which is x, k, and l, then you would have your new origin or new coordinates as x is equal to x plus h, y is equal to y plus k, and z is equal to z plus l. So this is the case when you're going to shift your origin to some other point. You're not going to consider your 0, 0, 0 as origin. So if you want to consider, instead of 0, 0, 0 as origin, you want to consider h, k, and l as origin, then in that case, your x, y, and z coordinates would be, small x would be x plus h. So where x plus h is where it is going to shift it to new origin, and h is you're going to be new point at that time. So the first question is the ratio in which a particular point, which is joining a line segment A and B, is equal to question mark. So now there is one point, say suppose that point is P, which is 7, 0, 1, and there is going to be one line segment. Say suppose that line segment is joining A and B. A point is 1, 2, 3, and B point is -2, 3, 4. In what ratio will this point 7, 0, 1 join this line? We have seen one formula earlier. The formula is, if there is one point which is going to join the line which is formed by joining the 2 points, that ratio is nothing but x1 minus x upon x minus x2, which is also equal to y1 minus y upon y minus y2, which is also equal to z1 minus z upon z minus z2. So just consider this point, x1 minus x upon x minus x2. In this particular case, your point x1 is 1, your x2 is -2, and your x is nothing but 0.7. Consider your point A, which is 1, 2, 3. Therefore, your x1 is 1, y1 is 2, and z1 is 3. Consider point B, which is -2, 3, 4. So your x2 in this case is -2, y2 is 3, and z2 is 4. And there is a point P, which has coordinates x, y, z, which are equal to 7, 0, 1. So I have to find in which ratio it's dividing, and formula for that is x1 minus x upon x minus x2. So x1 is 1 minus x, so -7. 1 minus 7 is -6, divided by divided by x minus x2. So x is 7, x2 is -2. So 7 minus -2, that becomes 9. Therefore, my answer is equal to minus of 6 upon 9. Minus 6 upon 9 means minus of 2 by 3. 3 to the 6, 3 3s are 9. I hope this point was clear. Just remember the formula. Formula is x1 minus x upon x minus x2. x1 in this case is 1, x is 7, and x2 is -2. Even if you consider y coordinates, y1 is 2, y is 0, and y2 is 3. So y1 minus y, that's 2 minus 0, which is 2, divided by y minus y2, that is 0 minus 3, which is -3. So answer is going to be 2 upon -3. 2 upon -3 is nothing but minus of 2 by 3. So the ratio is going to be constant even if you consider x coordinates, y coordinates, or z coordinates. I have to find the ratio in which my yz plane is going to divide this. So what would be the answer? We already seen formula for this. Type in your answers. Fast.
2.
Okay, so 3:2. Any other answers? Okay, type in your answers fast. Option 2 from Rutvik. Okay, any other answers? Omkar is saying second option. Okay. It's pretty simple. Like I said, if you're going to consider YZ plane is going to be the ratio for these two, then you have to consider the formula minus of x1 by x2. It's YZ plane. So consider third coordinate, which is not there. So YZ is there. So third coordinate should be x1 and x2. So formula is simple, minus of x1 upon x2. So minus of x1 is your minus 3, x2 is your 2. Minus of minus 3 by 2. That means 3 by 2. So answer is 3 by 2. Pretty straightforward. If you are considering YZ plane, consider x coordinates. Suppose the question was the ratio in which xz plane divides the segment. So in that case, what would be the answer? Xz plane, I'm saying. So you have to use the formula minus of y1 by y2. So minus of 4 by 1. In that case, minus 4:1 would be my answer. And if I change my question to the ratio in which xy plane divides the line segment, joining this and this, I'm saying xy plane. So my answer should be minus of z1 by z2. So minus of 2:3 would be my answer in that particular case. The midpoint of line segment, so it's pretty straightforward. You just have to add and divide by 2 to find the midpoint. So x1 plus x2 upon 2. So 1 plus 3 by 2 upon 2 is going to be 2. Similarly, 2 plus 4, 6 upon 2 is 3. That's going to be your y coordinate. And for z coordinate, 3 plus 1, 4 upon 2. So answer is equal to 3. I don't think there is any need to explain. You are just adding x1 plus x2 upon 2 and you get your answer. Center of a triangle, again straightforward formula. Formula is x1 plus x2 plus x3 upon 3. You just add and divide by 3. So x1 is 3, x2 is minus 7, x3 is 10. So 3 plus minus 7 plus 10 is 6, and 6 divided by 3 is 2. Similarly, for y and z coordinate find answers, you'll get your answer. So any doubt till this point? Type in yes or no if you have any doubts up till this point. No doubts from Rutvik. Okay. Others, Omkar, Pranali. Okay, Yash and Lokesh, no doubt. Omkar, no doubt. Good. Ruchika, Shruti, Srushti, Tanvi, Prathamesh, Neha, Yash. Are you getting? Lokesh. Okay. Others, are you understanding? Okay, Neha is saying yes, understood. Okay, good. We'll move forward then. You have to find the point which divides the line segment. This in the ratio 1:3. L is to M is given to you. L is 1, M is 3, and 2 points are also given. You have to use your formula Lx2 plus Mx1 upon L plus M. So directly use your formula. L in this case is 1, M in this case is 3. X1 is 2 and X2 is 3. Use the formula for internal division. You get your X, Y and Z coordinates. Find the ratio in which XZ plane divides this. It's XZ plane. So answer should be equal to your Y coordinates. So minus of 3 by 2. So that is going to be your answer. It is known that the 3 points are collinear. You have to find the ratio in which B divides AC. So simple. B is dividing AC. So you can use your internal division formula and get the answer. you found your AB, BC, and AC by using distance formula. And as the 3 points are collinear, I can say that there is going to be relation between these 3 sides. So what relation is going to be there? AB, BC, and AC. I can see that AB plus BC is equal to AC. AB is 2 root 3, BC is 4 root 3, AC is 6 root 3. So if I add AB and BC, I get my third side, which is AC. Therefore, which means that AB and C are going to lie on the same line, which means that they are going to be collinear. Now, I also want to find the point B in which it divides AC. I have already found out the ratio. So B is dividing AC in what ratio? It would divide in the ratio of AB is to BC. And that ratio is already known. The sides of AB and BC, I'll just put in there 2 root 3 and 4 root 3. Can I cancel out anything? Yes, root 3 cancels. 2 ones are 2 twos are 4. So answer is equal to 1 is to 2. You have to show that these are the 4 sides of a square. To show that these are 4 sides of a square, I can first find, say suppose these 4 points are A, B, C, and D. I'll first find AB, BC, CD, and AD. Values of all 4 sides should be same for a square. But would that be sufficient if I just show that AB is equal to BC is equal to CD is equal to AD? If all 4 sides are same, it is not necessarily a square. It can be a rhombus. It can also be a rectangle. If it is proving your conditions for square, it doesn't mean that it can't be a rectangle. Every square is definitely going to be a rectangle, parallelogram, and your rhombus and a kite. So what else or what condition would exactly show me that this is a square? Because just proving that my 4 sides are equal, I can't say that it is a square, because even in rhombus that may be true. I'll have to also show that there is one angle which is 90. But how can I do that? For that, I'll have to find one diagonal, and I'll have to show that that diagonal square is equal to the addition of other 2 side squares. Okay, so this is one way of solving. Is there any other way? Yes. I can find the diagonal of this. So suppose diagonal is AC, and then I can show that the relation between diagonal and side. For a square, the relation between diagonal and side is root 2 into side. Diagonal is root 2 into side times or root 2 into side of that square. Is there any other way that I can show that it is a square? Yes, you can also show that it is a square by showing that the diagonals are equal. So there are 3 ways in which you can solve this question. First, you'll have to show that all the sides are same. And second, you'll have to show that first option, that one of the side is 90 or one of the angle is 90. You can do that by verifying Pythagoras theorem. Second option, you can find the side and find the diagonal and show that the relation between side and diagonal is root 2 into side. Or third, you can show that you can find the values of diagonals and show that the diagonals are equal to each other. Okay, so the conditions is, in this particular case, we are going to see that all sides are equal and all the diagonals are also equal. So A, B, C, D, 4 points are there. So I will find A, B, C, D, 4 sides. All 4 sides are coming same. I'll then find my 2 diagonals. Diagonal values are also coming as same, root 18, root 18. Therefore, I can say that my 4 sides are same, 2 diagonals are same. Therefore, it is a square. Also notice value of diagonal is root 18 and value of your side is 3. So 3 means I can write that as under root of 9. So can I say that diagonal, which is root 18, is equal to 2 times into side, 2 times into under root 9, that is equal to under root of 18. So root 2 into side, this condition is also proved. Next, there are 3 points and I have to find the coordinates in which it is going to bisect the side BC. So I'll first draw the diagram, and in this diagram you can see if there is an angle bisector of, say, suppose angle BAC, that point D is going to meet the opposite side BC. It can meet internally or it can meet externally, but as it is an angle bisector, so it is obviously going to meet internally. I have to find the ratio in which it is dividing. So I have to find values of BD and DC. For angle bisector, I can say that the ratio of BD is to BC is also equal to ratio of AB is to AC, the ratio of the sides in which the angle has been bisected. And I can easily find AB and AC in these particular cases. AB would be, using distance formula, I can get AB, and AC would be, again, I have A and C point, using distance formula I can get AC, and the ratio of these two is what I want. So I can just find value of AB, it is 5√2, value of AC, and that ratio 5:3 is nothing but what I want. So it divides in the ratio of 5:3. If I also want that particular point, say suppose D, I can then find that point by using my internal division, which is Lx2 plus Mx1, because in this case now I have my ratio, which is 5:3. I also have the endpoints, which are B and C. So just using internal division, I'm going to get my answer, and this. So this is my answer. Okay, we'll stop over here. Tomorrow we'll continue with a few more questions. If you have any doubts, you can ask. Thank you, everyone. Pranali, Rutvik, Omkar, and who else is left? Yash, any doubt? Okay, no doubts. Perfect. Thank you then. Thank you, everyone.